I welcome all the students. So today we are going to learn the last point in this unit is keyframing system and motion pictures. So in the last session we have covered this unit up to the principles of animation. Okay, so we have learned up to this part. So today we are going to move or learn the last point in this unit. Okay, the name of the unit we are going to learn today is keyframing system and motion pictures. Okay, so we are considering how these frames are added, okay, in the and how we can generate this motion picture. Okay, so let us start our discussion. So and start learning the topic today: keyframing system and motion pictures. Let us start our today's discussion by learning first what is mean by the keyframe system. Okay, so last lecture we have seen animation, principles of animation, different techniques. So now we are focusing more on that, how we can generate this motion, how the frames, these keyframes are going to play an important role, okay, in the animation and the motion picture. Okay. The first point is we generate each set of in-betweens. Okay, generally we call it as these are the in-between frames. Okay, so we generate each set in between frames from the specification of two or more keyframes. Okay, so here the meaning thing that we want to mention is I'm giving, suppose this is my first frame, is my starting frame, and suppose I consider this is n is my end frame. So this is my first frame and this n is my end frame. Getting me? So in such a case, hey, I want to mention that this is my starting frame, this is my end frame, or these are the two keyframes. This is first and this is n. So in between, I'm giving this, generating the specification of the which keyframe should be used. Okay. Now we are going into the detail of this is motion path can be given, okay, with kinematic description as a set of spline curves. Okay, as we have learned all these types of curves, a set of spline curves or motions can be physically based, okay, by specifying the forces acting on the object to be animated. Okay, so in such a case, for example, suppose I'm giving that I'm going to throw a ball, okay, on the floor, then the ball may jump, it may be the bouncing, okay, it may be bouncing n number of times, it may take bounce 1 2 3 4 times. Initial bounce may be high, after it will be go slow, and at the end it will land on the floor. Okay, so this motion if I want to show, then definitely I have to use a set of spline curves in between, okay, from my starting to the end position, and this based on the forces which are acting on the object. Okay, whether I am throwing, I want to show that I'm throwing the ball with very high speed, so the bouncing will be very high. Okay, it is with the low speed or force is low, it will be jump with the, okay, low speed, and the similar way we have to animate. Okay, so this is what we are going to learn in the keyframe system. Okay, now for complex scenes, okay, we can separate the frames into individual components or objects. Okay, so we have to separate these frames. If the scene is complex, then we have to separate the frames into individual components or objects. Generally these are called as the cells, okay, which is a long form of cells is celluloid transparencies, okay, an acronym from the cartoon animation. So this word has taken from the cartoon animation. So we have to separate the frames into individual components or the object called as the cells. Okay. Now, given the animation path, we can interpolate the position of the individual object between any two times. Okay. So as I said, this is my starting keyframe. This is my end keyframe or second keyframe. In between, I have to add the frame so that I can show this. If I moving these frames from 1 to n by adding in between actions or the forces, okay, I will feel that it is become a animation or it is become a motion picture. Okay, so that is what we are considering. We can interpolate the position of the individual object between any two times. Okay, now with complex object, okay, the transformations, okay, the shapes of the object may change over time. Okay, this is very important. When I'm showing the animation, okay, and during the transformation, the shapes of the object may change over time. Okay, suppose I'm throwing the ball, it may be when the ball is bouncing first time, I may found that shape of the ball size is large. Okay, but as it is taking more step, okay, and it is moving far away from me, the shape of object may be going to change. It depends upon how I have to show the bounce of that particular ball. Okay, so it depends upon the object, okay, and the shape of the object may change during the animation, okay, and that is what we are considering. The examples are the cloth, the facial features, magnified details, evolving the shapes, exploding and disintegrating object, okay, and transforming one object into another object. Okay, so all these things are involved in the keyframe system. Okay, so we have to think about it. Okay, maybe the start position frame, the object may be looking differently, and at the end it may be looking differently. It depends upon the action, it depends upon the motion which we want to show for that particular object. Okay, so now here let us move to the next point to understand the things in detail. So I'm just moving to the next slide now. Just now we have seen that we have to transform one object into another object. Okay, so to show the motion, to show the produce the motion, so one of the very important technique which is used here, okay, which is known as the morphing. Okay, so the name of technique that we are learning is morphing. Okay, now what is morphing? So morphing is transformation of object shapes from one form to another is called as the morphing. So during this motion, during this change, okay, during this movement, I want to show that the object is moved from one shape to another shape, or there is a transformation object from one shape to another shape, and this is something which is known as the morphing. Okay, I repeat again, what is morphing is the transformation of object shapes from one form to another form, and we have to show that transformation. It should be considered as it should not be disturbing to the user, but that transformation should be very smooth transformation, and that technique that we are calling it as the morphing. Okay, actually the morphing, it is the shortened form of the metamorphosis. Okay, I think the word morphing came from the metamorphosis. Okay, the morphing methods can be applied to any motion or transition involving a change in shape. Okay, whenever I want to show the change in the shape of the object, maybe I want to show initially the faces of the, I consider as the a boy face converted into the girl face, or maybe the boy or the person is converted or changed into the animal face. Okay, so that was the, we call it as the morphing. So I want to the morphing methods are applied to any motion or transition involving a change in the shape of that particular object, or maybe the change into the some part of that particular object that we have to show. Now how we can achieve this, how this morphing can be achieved is, given two frames for an object transformation, we are giving two frames for the object transformation. We first adjust the object specification in one of the frames so that the number of polygon edges or the number of vertices is the same for the two frames. Okay, so I think for that we are going to see one example also, that how we can achieve this. This process is just now shown with the help of the diagram. So let us look at the diagram, okay, and how it will be visualized, how we can show this process. Okay, now you just look at this particular diagram. I think in the diagram I say consider this is the keyframe key. Okay, so what we are considering here is my key, suppose this is the frame number k, and now my next frame is my keyframe is k+1. Okay, I want to show that this particular object is transformed. This is my object in the frame k is transformed into the object k+1. So this is, I want to show this is transformed into this. So this is the straight line, and here now it is converted into this. I just want to show this transformation. Okay, I want to show the transformation from this to this. Okay, so an edge with the vertex position 1 and 2 in the keyframe k evolves into two connected edges in the keyframe k+1. So here I'm finding that in between 1 and 2 I have to introduce one more polygon edge, and I have to show that one is converted or one is connected to 3, 3 is connected to this 2, so this is in between I'm adding. Okay, so this is process I want to show, or in this diagram how we can achieve this. Okay, so let us understand this further detail of how this is. See, I'm taking it as a very simple object. I'm considering this is my keyframe number 1, and now I have converted it into this keyframe k+1, but I have to show this with the help of the transition. I want to show this with the help of the motion. I want to apply the motion. so that this particular keyframe K is converted into the keyframe K plus 1. So what I have to do, I have to add in between frames. I cannot show that directly. This maybe I consider as a straight line, okay, having this a triangular shaped line is converted directly to this. Okay, so I have to add in between frame. Okay, so let us understand that how we are going to achieve this. Okay, so we have to use the linear interpolation. So using linear interpolation of generates in between frames. I think just now I had discussed and told you what we have to do is we have to use the in between frames, add in between frames. We transition the added vertex in the keyframe K into vertex 3 dash along the straight line path as shown in the diagram B. Just consider that how I can add the in between frame to achieve this. Okay, now here I repeat again, what we have done is this is my original frame, K frame. I want to convert this object into this particular object. I call this is my keyframe K plus 1. Okay, from keyframe K to keyframe K plus 1, I want to achieve this conversion. Okay, but I cannot show in the motion directly this is moved from this to this. No, what I have to do, I have to add the in between frames. Here I am adding only one in between frames, but we can add more than one in between frames. Okay, I hope all of you understood what is mean by the in between frame. I can add one or I may add two in between frames. It doesn't matter. So depending upon the motion, depending upon the animation, I have to add these frames, which I'm calling it as the in between frame. So halfway, what I'm showing that. So this is my added point. Okay, first I have showed that this is my, because I'm initially I'm having only this and this point. So I'm adding one point. This added point is now here, it is moving. You can find it here. It is moved to this, and then it has moved to at this as C dash. So this adding one point, and then it cannot be converted directly at this point, but in between it is. So I have to show add this frame. Okay, so I repeat again. So what we have learned through this diagram is linear interpolation for transforming a line segment in keyframe K into two connected line segments in keyframe K plus 1. Okay, so in keyframe K plus 1, two connected line segments in keyframe K plus 1, and this is what we have to achieve. Not necessarily this. Here I can add one more frame also. Okay, suppose I want to in my another frame, I just want to show it has moved in something like this. Okay, so that angle is little bit less. Here again I can show one more frame. So it depends that how many in between frames we want to add in my keyframe. Okay, so this is the method that we are having. So we have to think very important is this is my keyframe K plus 1. We have to decide that how many key in between frames we have to add depending upon the transition time and how much the object had changed. Okay, so I'm just moving to next slide so that the things will be with the another example, the things will be made more clear, okay, for understanding of the keyframes. Okay, see here the what is the meaning of the keyframe. I want to just consider what is mean by the keyframe is, see, this is my keyframe because this is my starting position and this is my, I want to achieve this. Okay, so this is my keyframe K, important frame, and K plus 1. Okay, but I cannot show the movement from this to this. The object cannot be converted directly from this to this, so I have to add in between frames. Okay, so that is what we are considering the method which is applicable or the process that we are going to apply for this. Okay, so let us move to the next slide to understand the details further. An example of a triangle linearly expanding into a quadrilateral, okay, is given into, or I call it as it is converted into a square also. Okay, so we are considering having initially only 3 edges, converted into quad means I am converting into the 4 edges, or you consider as in the square shape is given into the diagram. I want this diagram is very important for your understanding of what is mean by the morphing example and how we are adding the in between frames. Okay, so let us focus on the diagram now. So now you can find the same thing I have shown with the help of the diagram. This is a linear interpolation for transforming a line or the triangle. So what I want to do is my keyframe K is my triangle. Getting me? So in the morphing process, I want to convert that. This is my original object, that is the triangle or the keyframe K. is converted into keyframe k plus 1. So it is converted in around, I consider as a having the quad means 4 points. Here I am having only 3 edges or 3 vertices, connected to 4, and it is more similar to a shape of a rectangle. Okay, or maybe a square, you can consider square or related to the rectangle shape. Now in the motion I want to move from this to this. See, this is my source, this is my starting, this is my end. Okay, but now what we have to do in the morphing, we have to show that how I will cannot show through the motion or animation directly this to this. I show triangle and directly I will show this as a square. No, it is, I have to show that the change has occurred, the transformation has shown, the motion has to be shown in the animation. So what we are going to do, we are going to add this frame in between. Okay, so this shows that the triangle is slowly, smoothly converting into the rectangle shape. Okay, and now suppose I consider this is my one of the point. Okay, I'm adding one more point over here, and now this point I'm just moving, so the point will come here in between, and now this point reaches at this stage at in the last frame. Okay, so this point I maybe consider here, I'm just goes on stretching this point. Okay, I just go to stretch this point, so in between the point come here, again I stretch, the point comes here, and now you can find if I'm just going to stretch this point, this triangle is converted, how it is means if from the 3 vertices it is converted into the quadrilateral. Okay, how it is converted. Okay, so this is what the process that we have to show with the help of the morphing. Okay, and this is what the basic principle or the process behind the morphing. We have to convert one shape from one to another, so we have to add in between frames. So I again repeat, not necessarily this will be only one keyframe, we may need to add n number of keyframes, maybe 2, 3, 4, depends upon the what type of the motion we want to achieve and what type of the transformation we are having and how much time we have to give for this transformation. We have to show that triangle is converted into this just within a 30-second. Okay, then appropriately I will add this frame. I have to show only for 10 seconds this should be conversion is there, I add only one frame. I want to show that within 1 minute, okay, I'm having 1 minute of time to show the conversion from this to this, so definitely I will require a more number of in between frames are required. Okay, and similarly we are going to add all these frames, okay, in between. Okay, and to achieve this, the morphing effect or the transformation effect of conversion of object shape from one shape to another shape. Okay, so let us continue our discussion. I'm just moving to the next slide now. Okay, now this is why we have added this. Okay, definitely the reason is why we have shown this diagram, because just I want to show that the transformation of an STP, okay, oil. Okay, so we are having this as the oil box, okay, into the engine block. So my initial diagram, my diagram number A is my keyframe K. Okay, I want to show the morphing or the transformation. From this it is converted into the object that is my engine block. Okay, so oil box, okay, is converted into the engine box. Now you can find this is my original shape. I want to achieve the transformation of this into this. Okay, so definitely I cannot add only one keyframe. Okay, I think the only one keyframe will not solve my purpose. So here, how many in between frames we have added? We have added this is my in between frame number 1. This is my in between frame number 2. This is my in between frame number 3, which shows that smooth transition from the object of the engine oil or STP oil into the engine block. Okay, so we are considering this is STP oil box is there. It is next step, it is just converted into this, next again it is this, and finally I can show that this is converted into the engine oil. Okay, appropriately it is converted into this particular part. Okay, and this is what I want to achieve in the morphing. Okay, I cannot show this frame and directly I cannot show this frame, but I have to show the process, I have to show the motion, that how the object, this object is going to change the shape from the STP oil box into the engine block. Okay, so that's why I have added this diagram, so that the concept or the thing will be with this example, it will be more clear to you. Okay, so I am going to show one more example for you. Okay, that will help to clear the concept of the morphing and okay, the technique behind it. Okay, so just moving to the next slide now. Okay, I think this is a very good example or the very good diagram which shows the morphing effect. Okay, this is what is showing. This is my original object, is my car. Okay, so I'm having, this was my original object. Okay, so transformation of a moving automobile, or this is my moving car. In the moving, in between it is moving. Okay, in between this drive, okay, it is converted from this directly, it is converted into a running tiger. Okay, I want to show that the speed of my car in my advertisement. Okay, I will achieve, the car is having the speed which is similar to the running speed of a tiger. Okay, so it is I want to show it is similar to this. Okay, so transformation of a moving automobile in car into a running tiger, okay, is shown over here. But again the same thing, in the morphing I cannot add this car frame and directly to this one. I cannot move directly from this to this. I think that will be disturbing to the user. Okay, they will surprise that how the car is converted into the running tiger. Running car is converted to a running tiger directly. Okay, it is not possible to do it directly. So we are adding in between frames. Okay, so that what the, this is my keyframe 1, this is my K, and this is my keyframe K plus 1. Okay, so from keyframe is important. Key means this is my original frame, this to this. But to achieve this, I'm having to add it to in between frames. So here you can find the first keyframe. You can find that the first or the starting part of the car has converted into the face of tiger. Okay, so it is moving. So I have to show this frame. It is just moving from, some part of this is moved. Here you can find the almost 50% of the part of the car has converted into the running tiger, and then we can change the remaining 50% part and it is converted. I said this is not compulsion. I can add one more keyframe in between where I can show that 75% of the part of the car is converted into the tiger, and then I will achieve. So it depends, okay, on the how many in between frames we have to add, which will help me to have a smooth transition, which help me to show the smoothly the running car is converted into the running tiger, or maybe the running tiger is converted to the running car. Okay, so as per appropriately we have to do. So this is what the concept, okay, of the morphing that we have learned. Okay, so let us understand. I am just explaining the concept of the morphing, which is comes under the keyframing systems, which is the one of the technique which is used under the keyframing technique. And I have shown these two examples which will clear your concept of converting the one object, shape of the object from one shape to the another shape. And whenever we are showing this with the help of the animation or the motion, definitely we need to add the keyframes in between. Okay, and this is what all about our consideration of the morphing. Okay, so let us continue our discussion, because we have to learn not only the keyframing system, but we are going to learn the motion picture also. Okay, so I'm just moving to the next slide to clear or understand the next point as per our. Now here, this is very important. We have to give that how we are giving the motion specification. Which are the motion parameters we have to specify? Okay, we have seen in the example. Okay, now we have to consider the specification. See, there are several ways in which the motion of objects can be specified in an animation system. Okay, so which are these several ways, which are these methods to specify or to specify the object? Okay, and it is how it is specified. Okay, so I'm having the first option is direct motion specification. So I want to give for the direct motion specification. So the first method or the first way is direct motion specification. So we are talking about direct motion specification. Now, it is the most straightforward method for defining a motion sequence is direct specification of the motion parameters. Directly, I am going to specify all the motion parameters. Okay, so that is my direct method of conversion from one object to the another object. Now here we explicitly give the rotation angles and the translation vector. So all this such information, all this specification we are directly giving. Okay, so it is called as a direct motion specification. Explicitly, we are going to give the rotation angle as well as the translation vectors that we are going to give. Okay, now then the geometric transformation matrices are applied to transform coordinate position, as we have learned that. Okay, whenever I am to convert one object into another object in my normal transformation, we have learned in 2D transformation and the 3D transformation, I have to specify my transformation matrix. Okay, it is similar as I'm specifying the scaling matrix, I'm specifying the rotation matrix. Okay, I'm specifying the translation matrix and so on. So then the geometric transformation matrices are applied to transform the coordinate position. Okay, alternatively, there is another alternative. What we can do is we could use an approximating equation to specify certain kinds of the motion. Okay, so if we have to somewhere we have to approximate this equation to see that whether we are going to achieve this motion appropriately or not. So it is not exactly by all the parameters that we are having. For example, I have to show that the conversion is having the angle 40%. Okay, but it is not having the same effect. I may need to change that. Instead of 40%, I may apply 30%, or may I apply 30% angle, okay, or 30-degree angle rather. I say I may go for the 45-degree angle. Appropriately, we have to approximate the certain kinds of the motion. Okay, now in my motion specification, okay, so we are just considering this formula that we are having is motion specification. We can approximate. Now how I have said we have to approximate this path. Okay, so we can approximate path of a bouncing ball. Okay, we have to approximate the path of a bouncing ball, for instance, with damped rectified sine curve. So I'm using the formula y of x is equal to a. Okay, so generally we are giving this as the value as a as amplitude, sine wx into theta angle into e raised to minus kx. So I can specify this formula directly, okay, and appropriately I'm going to do, where a is initial amplitude, as I said, a is amplitude, w is the angular frequency, okay, theta 0 is the phase angle, and the k indicate a damping constant that we are having. So I can specify all this with the help of the equation. Now these methods can be used for simple user program animation sequence. Okay, can be used for simple user program animation sequence. Okay, now I think this diagram, okay, which will make you more clear, okay, with the understanding of this, approximating the motion of a bouncing ball with a damped sine wave function. If I'm using, see here, what I want to show in this diagram is, here I want to show that I am showing through the ball. Ball is thrown at this particular height. Okay, at this height I'm just throwing the ball. So here the ball will have impact on the floor. Here it is going to bounce again. So obviously first it will be bounced very high, then the bouncing will be, height will be low, again it is low, again it will be low, in this way, and maybe at the end it will settle down. It is settled down at this particular stage. Okay, and this is what I want to show with the help of the motion specification, and I want to achieve, I want to show. Getting me? So here I'm just throwing this particular ball at this. Okay, so now can I show directly this ball, and the next frame I can show directly this ball? No, it is not possible. I have to add in between frames. This and this position should be added. That will help that the ball is moving from this point to this point. Okay, again it is, I cannot show directly this to this. Okay, but I have to add somewhere this one more frame so that the ball is moving up, okay, in this direction. Again I have to add to all these in between frames, all these things, all this judgment I have to apply whenever I'm going to show the motion picture. See, this is what the clear-cut example of the motion picture. Getting me? This is our last point that we are discussing. Okay, so in the motion picture, now in this case, here I'm having n number of keyframes. Huh? I'm not saying that there is only k. Suppose this is my keyframe number k. This will be maybe my, this is my k plus 1. Okay, this is my k plus 2. This is my k plus 3, okay, and so on. K plus 3 and so on. I'm just doing this dot, but I have to add all these in between frames. Now here you can find, suppose this is, I consider it my one of the keyframes. Okay, this point. Look at the diagram, and suppose this is my another keyframe. Okay, now here you can find this keyframe and this keyframe both are at the same position, but I have to generate this. So I may take this as one of my keyframe. I will add this in between frame, this ball, then only I can achieve this motion. I can achieve that, yes, this is moving in this direction and this is settled down. Okay, I'm hoping, or I'm very sure that you are cleared with the help of this bouncing ball example how this motion picture can be achieved. Okay, and how there is, why there is need to specify all these values. I have to specify the amplitude. I have to show, here we are using the sine function. Okay, so directly we are using sine function. Okay, we are considering how much frequency is there. Okay, frequency means number of times that we are having, how it is changing, what is the phase I have to shift. Okay, all these values are given or parameter. So this comes under the direct specification method, okay, of the motion picture. Okay, so let us move to the next point. Okay, so understand the two more method, okay, or the another method that we are having, which we can specify or we can use for the motion picture. Okay, I'm just moving to the next slide now. So here I just consider another method is goal directed system. Okay, goal directed system. Okay, this is very important method which is used in so many different motion picture or the animation. Okay, what it does, at the opposite extreme we can specify the motion that are to take place in general terms, not in the kinematic terms. Okay, I'm giving not so many amplitude, the frequency, the angle, I'm not giving, I'm just making it as a general term that abstractly describe the action. Okay, so I'm just giving the general term, and the animation or the designer will going to specify or find out how it can be achieved. Okay, instead of giving the exact or direct formula for conversion, I'm just specifying the general terms that will help us to provide the motion. So that's why it is called as the goal directed. It is called as the goal directed system. The systems are referred as goal directed because they determine specific motion parameters given the goal of animation. I want to achieve this goal. I'm just giving this goal. And this is my starting position. This is my end position. I want to perform this particular action. Okay. So I'm just giving the goal. Okay. And another parameter, motion parameters will be decided by the computer itself. Okay, or computer or software or the programmer is going to decide this parameter and achieve this goal. So that's why it is called as a not direct method, it is called as a goal directed system. Okay, now for example we can specify that we want an object to walk. Okay, I'm just considering that what action I want to show, what motion I want to show. I want to show the object should walk. So I give, this is my starting position of the object. Okay, I'm just drawing it here. This is my object starting position and this is my object end position, and I want to show the object is running. So my computer will specify the parameter. It will take into account what is the height of this particular object, what is the speed of this particular in general object, with how much speed it is, whether it is walking fast, whether it is walking slow, okay, or whether it is run. I'm giving the action here that the object to run. The object is walk, the object to run to a particular destination. So this is my source and this is my destination I'm going to specify. So this is my goal is the object should walk. I want to show that the object to be run. Okay, I've just specify general speed, whether it is fast, slow or medium. Okay, I'm not specifying here the object should run with 20 kilometer per second. I'm not specifying. I'm just specifying whether the object is running fast, whether the object is running slow, very slow, or the object is running with the medium speed. Okay, so general terms I'm specifying. Okay, and my computer animation software or my computer will decide how I can achieve this motion. Okay, so that's why this is called as and nowadays so many softwares are available which will provide you or give you directly such motion. So this is called as goal directed system. Okay, or we could state that we want an object to pick up some other object. Okay, I want to show that my object is picking some object and just a pick up. So it will move from the bottom to the top. The object is moved, it is going to pick up the thing. So all this thing we have to specify in my goal directed system. The input directives are then interpreted in terms of component motion that will accomplish the selected task. Okay, so I think this is one of the important method which is easy for the user to specify to give the input to achieve the motion. Now, as we have learned, okay, these are the different types of the motion. We are having another method or the way that to achieve this motion picture is, okay, that is kinematics and dynamics. Okay, so we are just considering this is the last point that we are going to learn for today's session, kinematics and dynamics. First two method we have learned, okay, which is generally used, okay, but we just want to clarify these two terms. We can also construct the animation sequences using the kinematics or dynamic description. I want to give this. Okay. Now, what we are giving in kinematic description? So in kinematics description, we specify the animation by giving motion parameters. So if I'm applying this method, I have to give this motion parameter, which are this position, it is moving with what velocity and what acceleration that we have to specify. So if I specify this parameter, I think I'm taking the help of the kinematic parameters without reference to the forces that cause the motion. So I'm not considering that, which are the I'm not going to take the forces, okay, that we are considering into the direct motion specification. So we are not considering the references of the forces which are applied to that or which is going to cause the motion. Rather, I'm going to consider the motion parameters into the kinematic description, okay, such as position, velocity, and acceleration. Now, for constant velocity or zero acceleration, we designate the motion of rigid bodies in the scene by giving an initial position and velocity vector for each object. So, suppose I am not giving the constant, or suppose I want the object is moving with the constant velocity, or I consider that the acceleration value is 0. Okay, then we designate the motion of the rigid object in a scene by giving the initial position object and what is the destination position of the object and the velocity vector for each object that we are giving. Okay, now an alternate approach that we can also achieve, and it is called as the inverse kinematics. Okay, I think this is also one of the very good method that we can achieve the motion picture is inverse kinematic. So inverse kinematic, we have to identify the parameter. Okay, so this is what we are here. We specify the initial and final position. This is very good. Okay, this is one of the another method that we are having. Specify only the initial and final position of the object. So as you just have seen that this is my original position of the object and this is my end position of the object. Okay, initial and position of the object as specified time. And so that I want to show that this object is moving from this position to this position and the action is this object is running. Okay, and to move from this particular source position to this as my destination position, suppose I specify that I have to show this position or motion into the 30 seconds. I am specifying that how much time it is required for the object to move is 30 seconds. Okay, so at specified times and the motion parameters are computed by the system. So I'm just giving this is my start position, end position, this much the length, and I want to show that the object is running from the source position to the destination position in 30 seconds. This is specified by user now. And what my computer is going to find out now? So it is going to find out the motion parameters are computed by my system. So my system is going to compute these motion parameters. Okay, I think now so many software things are available which is going to generate this particular thing. How much time I have to set. Okay, so if I say that this object is moving from this to 30 seconds, it may be medium. Suppose I specify 10 seconds, I want to show the it is running. Okay, so it will be fast. If I say it is 1 minute, so it will be slow, and accordingly my computer is going to compute or calculate the motion parameters, and this is something which is known as the inverse kinematics method, this method. Okay, so that is what I have specified or we have discussed here. Okay, now, for example, assuming the zero acceleration, okay, we can determine the constant velocity that will accomplish the movement of an object from the initial position. So, for this particular example, okay, this example, it will specify what should be the velocity I have to consider, okay, what should be the acceleration I have to consider. Okay, so all these parameters it is going to specify or the it is going to find out. Let us learn what is now mean by the what we are going to do in the dynamic. Okay, so this is what we have discussed about kinematic, okay, parameters, kinematic parameters. Now let us understand about the dynamics. Okay, so just consider this. Okay, the final position. Now coming to the conclusion of the session now. So let us understand the dynamic description on the other hand require the specification of the forces that produce the velocity and acceleration. See here in dynamics we have to take into account which are the forces, which are the source of the force, okay, that we are going to apply, okay, to that particular object. Okay, whether one person has pushing one person and then it is falling down, or the person is okay, fail, okay, or the falling down directly. Okay, so we have to specify the forces in the dynamic description. the description of objects behavior under the influence of forces are generally referred as a physically based modeling. Okay, so this is the third way or the third method that we are using for the motion specification or the motion picture. So we have to specify the description of object behavior under the influence of forces. So just I say that whether one person is going to push another person, okay, and that person fall down. Okay, so what is the cause? Okay, what is the behavior of that object and which force is applied? Okay, why the person has fall? Because due to the one another person has a person is going to push that particular person, or is there any other object that is going to hit that person and the person fall down? Okay, so this is such type of the influence of the forces. If we specify, then it is known as physically based modeling. Okay, that is also used in the motion picture. Example of the forces affecting the object motion includes electromagnetic force, whether it is the gravitational force, whether it is a friction, or whether it is other mechanical forces. Okay, that we have to specify. So we have to consider that which type of the force has made this object to move or has given the motion to that object. Okay, whether that force is electromagnetic, whether it is the gravitational force, whether it is a friction, and other mechanical forces that we are going to specify. Okay, and that is what we are considering here. Okay, so I think we have reached to the end of the session today. The application of physical based modeling include complex rigid body system and such non-rigid system as cloth, plastic and material. Generally, all this physical based model is used for the motion of the, I call it as the complex rigid body system. Okay, means I'm not talking about the person or the human being or maybe the animal. And generally I want to show the movement of a cloth. I want to show the movement of the rigid system. I want to show the movement of a heavy weight object. Okay, heavy equipment operator. Okay, that I have to show. Generally, in such a cases, we can use the physically based modeling. Okay, so this is all about the today's session. Okay, where we have started learning about the keyframing system and the motion picture or motion specification. We have learned one of the important method of the keyframing system, that adding the in between frames and use of the morphing method, and the motion specification, which are the different types are there: direct specification, goal based, okay, indirectly how we can specify, okay, kinematics and dynamics and so on. Okay, so I hope all of you have not only understood the unit, okay, but I hope all of you have enjoyed listening to the lectures of the our very interesting subject, okay, computer graphic system. Okay, so we have learned this computer graphic system. Today is our last session or the last lecture of this subject. Okay, so that's why I have said that definitely all of you have understood and enjoyed learning the computer graphic subject. Okay, thank you all the students.